Alright, so CNT125, Chapter 8, we're starting to work into our subnetting. We just did our fundamentals. Now we want to talk planning. If I'm going to create a certain amount of subnets, I need a way to figure out how I'm going to get that. It isn't just a matter of I'm going to borrow a couple bits and hope for the best. I actually want to kind of plan out what I'm going to do. So, Mr. Brown, lack of better terminology here, I just say subnet planning. That's what we're going to call that. So we know there are two addresses not usable, the network address and network ID and the broadcast address. Network ID is all zeros in the host portion. Broadcast address is all ones in the host portion. We also know we have two rules. When I borrow bits to create subnets, I'm going to borrow left to right from the host portion. And I'm also going to make sure there's 2 bits left in the host portion when I'm done. 2 bits left in the host portion when I'm done. Okay, so can I figure out how many bits to borrow or leave behind to plan on a network? Yes, I can. I can use my powers of 2 to help. If you remember when you learned your binary place values, we had this little, our binary place values 1, 2, 4, 8, 16, 32, 64, 128, and these are really being derived from the exponent. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, because it's 2 times 2 times 2, 2 to the 4 is 16, 2 to the 5 is 32, and so forth. Okay, if we use this, this can help us. Here's how this helps us. If we have a Class C network, okay, we have a 220.45.35.0 network ID. The default subnet mask is 255.255.255.0, and here's our default subnet mask in binary. Okay, totally completely nerded out here. If we borrow 2 bits from the host portion to create subnets, right there, those 2 bits, remember, left to right from the host portion. If I borrow those 2 bits left, or 2 bits, I can use my binary place values up here and say, okay, 2, binary, base 2, if I borrow 2 bits, 2 to the 2, tells me I can create 4 subnets. This also tells me with 6 bits left, 2 to the 6, up here 2 to the 6, I'm going to get 64 addresses per subnet in the host portion. I'll have 64 addresses per subnet. So I'm going to create 4 subnets. Each one is going to be a piece, a group of numbers 64 big, 64 numbers large, if you will. So I'm taking this host portion, breaking into 4 pieces, and each piece is going to be 64 numbers large. That's what this is all telling us. And it's just based on simple math of my octet, of my 8 bits of my binary system. That's all this is. So if I'm going to borrow 2 bits, I can say 2 to the 2. 2 to the 2 bits borrowed is going to give me 4 subnets. I can also say with 6 bits left, 2 to the 6 is going to give me 64 addresses per subnet. And I also know, you notice I put down here 62 usable. 62 usable because if I back up, one of the addresses is going to be a network number and the other one's going to be a broadcast address. Those 2 are going to be subtracted out to give me 62 usable. You're going to see that going all throughout, so we'll just explain that right now, why we're subtracting 2 right off the bat. If I have a Class C network, and subnet mask, default subnet mask, here's my default subnet mask, and I borrow 3 bits from the host portion, 3 bits right here, 2 to the 3 tells me I'm going to get 8 subnets created. And now that I've borrowed 1 more bit for subnets, I have 1 less bit for host, don't I? So I'm going to get more subnets, but I'm going to get less nodes per subnet, because I'm taking the 0 to 255 and breaking it in equal pieces. I cut more pieces, each piece is going to be smaller. Okay, it's like a little teeter-totter, a little balancing act here. So 2 to the 3 bits borrowed is going to give me 8 subnets, but each subnet is now going to be 2 to the 5. There's only 5 bits here. 2 to the 5 is going to be 32 addresses per subnet, of which, subtract 2, 30 are going to be usable. Okay, if I borrow 4 bits, Class C network, 4 bits borrowed, 2 to the 4 is going to give me 16 subnets. 4 bits are left, less bits now, 4 bits left. 4 bits left, 2 to the 4 bits left is going to be 16 addresses per subnet, of which 14 will be usable. Okay, so I'm creating more subnets, but each subnet is getting smaller. 5 bits borrowed, 2 to the 5 is going to be 32 subnets. 3 bits left, 2 to the 3 bits left is 8 addresses per subnet. If I have a Class B, I have more bits to work with. So in this case, if I borrow 4 bits for subnets, 2 to the 4 is going to give me 16 subnets. I now have 12 bits left. So 12 bits left, 2 to the 12 is going to be 4,096 addresses per subnet, of which 4,094 will be usable. Class B, more bits to work with. I have more addresses at my disposal. Class B, 6 bits borrowed. 6 bits borrowed, 2 to the 6 is going to give me 64 subnets, and I now have 10 bits left. 2 to the 10 is going to give me 1,024 addresses per subnet. Okay, so again, Class B, more bits to work with. I'm doing the exact same principle, I just have more bits I'm working with. And I can actually borrow. You notice I'm borrowing all 8 of these and 2 of these. I can do that. I'm not violating the rule. Left to right, I'm leaving 2 behind, more than 2 behind. So I'm not violating the rules here. 2 to the 10 bits borrowed is 1,024 subnets created. 6 bits left. 2 to the 6 is going to give me 64 addresses per subnet, of which 62 are usable. If I zoom out to a Class A, many more bits to work with now. But I can borrow 5 bits left to right here, and I'm now left with 16 plus 3 is 19, okay? So 2 to the 5 bits borrowed is 32 subnets. 19 bits left. 2 to the 19 is going to give me 524,288 addresses, of which 524,286 are usable. I can borrow up to 8 bits. I can borrow that whole octet. Ooh, now you'd have to pay attention, wouldn't you? If I borrow that whole octet, it's going to look like a Class B network, but it's not. But 8 bits borrowed, I'm going to get 256 subnets. I'm left with 16 bits. 2 to the 16 is 65,536 addresses per subnet, of which 65,534 are usable. Okay, so I can use this planning. I can use my powers of 2 as a planning tool to figure out what am I going to get before I even dive in and do all this work. Because we still need to do the work yet, but I need to figure out what I'm going to get. Here's one more Class A. I can borrow, as you notice, 8 here and 4 more here. I can borrow 12, and that'll leave 12 behind. That's a break even, isn't it? So 2 to the 12 bits borrowed is going to be 4,096 subnets. 2 to the 12 bits left is going to be 4,096 addresses per subnet, of which 4,094 are usable. That's my break even. That's right smack in the middle. So, with all that planning, that gives me a quick ballpark, almost like a little barometer of what am I going to get. Once I know that, I figure out how many bits I'm going to borrow, then I can go to town and make it happen. So the next thing I tell you here is, okay, if I do this, I do need to communicate with the nodes on my network, with my routers, with my devices, with my subnet mask. I have to let my subnet mask know what I'm doing. So I pretty much put these examples right back for you and said, okay, with a Class C, if I borrow 2 bits right here, here's my 2 bits borrowed, all I need to do is convert that into decimal number, in this case 192, and my bit count. So 24 plus 2 more is /26. With that subnet mask knows what I'm going to do. The devices in my network know with that subnet mask what I did or what I'm planning to do. If I have 3 bits borrowed, convert to decimal, I get 224. Out of my bit count, I get /27. 4 bits borrowed, there it is, convert to decimal, 240, /28. Okay, I think you're starting to see the binary to decimal conversion being really important now. 5 bits borrowed right here. 5 bits borrowed, I'm going to get 248 or /29. Same exact thing was going to apply for Class B and A. I just have more bits to work with, more to keep track of. So normally 255, 25500, 4 bits borrowed, this is going to become 240.0, and it's a /20. Again, there's 20 bits in the subnet mask right there. There they all are for you. 6 bits borrowed on Class B, 255.252.0 /22. I can have a Class B where I borrow 8 plus 2 more, couldn't I? So now I'm going to get a 255.255.255. It's looking like a C network, 192. So you need to really pay attention to this first octet in this subnet mask to know what's going on. And this is a /26. This is the /26. Class A, I can borrow these 4 bits right here. Or excuse me, borrow 5 bits right there. So I end up with 255.248.00 /13. Borrow 8 bits, 255.255.00/16. Borrow 12 bits, so these 8 plus 4 more, so I end up with 255.255.240.0, so /20. Okay, so it's just kind of a record keeping, But the borrowing bits, I can use my binary place values and my powers of 2 to know exactly what I'm going to get. Once I do that, I just need to communicate that with my with altering my subnet mask so routers, switches, nodes know what I did for my subnetting. All right, we're going to come back in the next podcast and actually do our first subnetting exercise of taking a network and breaking it into pieces.